Alright, still up. So figure I'll make another video. What the hell? Try to get to this in some way that it's understandable. I guess it's just going to take writing up a bunch of bullet points and trying to find people willing to argue the single points. Trying to make statements as clear and explicit as possible. You can't just use the word particle because people have all kinds of definitions of particle. You can't, and certainly the word wave doesn't mean much. No way to make that make much sense in the sense that the standard wave in reality is this spreading pressure field that moves, not just a single object. You can't. It's hard to call a single object that moves in a discrete, confined motion a wave. It just doesn't fit. You shouldn't have the same word for things that are very different in how they function. So we have this subject, electromagnetic. Right there, that word itself is where all of this turns into garbage. Combining these things, and although they end up being related things like charge and magnetism, they're not the same thing, and the distinctions need to be understood. So let's just start with something that maybe people could agree on. So maybe I'll draw some crap first here. So the idea of the charges, the proton and the electron. All right, and so this is the electron, the negative. Here's the proton, positive. So just to make distinction. And so let's just put them in empty space. Now there's no field, okay? There's no anything. There's just a thing called a proton and a thing called an electron. And what we kind of know is that they're going to behave inversely. That is something that's going to happen around them. There'll be a thing, and that thing will mean the proton will act completely opposite to how the electron will act when that thing exists. So you could understand that if I made the thing, a little positive thing, that this little positive thing would end up, if it hits this proton, moving the proton, and if it hits this electron, the electron will move the wrong way. Okay, through some sort of magic. Okay, the red thing will hit it and it'll somehow move the wrong way. Obviously that's not going to happen, but that's what we see. And so then all I have to do is create another little thing of the same form, but it has the opposite color, and it'll do the opposite thing. If it hits the electron moves away. But if it's a proton, the proton moves towards it. It moves in the direction opposite to what the thing was moving in. The momentum is somehow conveyed the wrong way. So what we know about the universe is these things don't move the speed of light. And then I think some people might be willing to accept that they don't have any innate velocity of their own. That through their life experience, they acquire velocity. So if they are actually moving through space at some speed, it's because they had an experience previously that gave them that speed. Something pushed them. Okay? Not likely pulled them, but pushed them. Alright, so let's just say this is your universe. Alright? We have the basic components. We have something we can make an atom out of, and we have something we can make a force out of. So let's just say these little things always go the speed of light, and these things only go the speed that they've had interactions with. So if something hits them and gives them momentum, they keep that momentum until something hits them going the opposite way and takes it away. So, that seems a simple enough way to understand it. So fundamentally what's being argued is that all the big stuff in the universe and all this little stuff, this is the one universe, this little stuff. And this little stuff combines to make these things we call big things. They're going to be full of these electrons and protons that will be in the shape of atoms, configurations. And so they're all going to be full of these little atom bits, these electrons and protons substantially. You can add a whole bunch of little crappy other particles if you want, but I don't think there's any need to because they're all sort of imaginary and made up. And the idea is this force stuff, this little stuff moving the speed of light, we know it has lots of forms. So it's in the form of gravity. We'll use a G. See that G there? Yeah. And it's in the form of magnetism. And we call something the electric field, but the electric field, okay, as a field, is just a form of magnetism, really. Electricity is something completely different than the excreted field of a magnet. Electricity happens inside of conductors. It happens as a thing that atoms do with each other, not something that happens in free space. When it's in free space, it's not electricity. It's in this form of this force stuff, and the force stuff is in the form of magnetism and gravity primarily. So this E field is really a doubtful field. It doesn't really need to exist. You can just understand it as a dipole field of magnetism, that is, both poles are present, or the single poles. So you can understand that magnetism has two polarities, and that all you're really talking about is when you separate those polarities by distance, then you have charge. You have the electric field. But anyway, I don't want to get too specific. So the idea is you have this matter stuff in the universe, and the idea is the field stuff, the energy, is all over the place, just filling the universe full of pressure. So it comes into everything. And it's mixed, the two little kinds of energy, right? The stuff that reflects electrons, the stuff that reflects off of protons. And it basically goes into everything, and some percentage of it, a tiny percentage, but some percentage of it, right, stays in the thing, and the rest just goes straight through. And so in the case of regular pieces of matter, it goes straight through from all directions, and so it comes out the other side, and it's coming out the other side, and it's going to be doing the same thing. It's going to be coming out mixed, generally speaking. And that's understandable, right? That's not too taxing. We understand that matter atoms are mostly empty space, so we can sort of understand that these little tiny bits, could travel through things and, end up being transmitted through them as a force. I mean, they're really transmitted as a force through, but, you can imagine it could get, some percentage gets through. Whether you understand that they move through in fundamentally the same form of pressure, but the thing that goes in won't necessarily be the thing that comes out. It's just going to be that a blue bit will go in and another blue bit will come out, but they're not the same blue bits necessarily. That they just kind of make exchanges with each other. And so the amount of momentum that goes in is the amount of momentum goes out. And if there's any difference, if this, does not equal this, then that means this kept the difference. And it's now moving that difference. So, I mean, it's kind of simple, right? This isn't demanding too much from you people, right? And then the trick is that if you arrange this stuff in such a way where you have some material body that is composed of certain amounts of imbalance in its structure of these electrons and protons, that is, it has more facing one direction than facing another direction, and I'll do that as a gross illustration just by putting all the reds down here and the blues at the top. But the idea would be is each one of these would be red and blue, and they'd all be lined up in a certain way. That would be called a magnet, a dipole magnet. So that thing is an entity. And so when the stuff comes into that, what's going to happen is any blue stuff that hits is going to reflect off the blue, so it's coming back out blue. And it's going to leave in a different direction if it's red. So the red is going to end up going this way. It'll take a turn towards the red end, and it'll come out one of these directions as red energy. And the same will be happening to the blue. So here you have all the red energy that hits up here will end up coming out this end. All the blue energy that hits up here is going to reflect. So there won't be any blues coming out of this end. I mean, any reds coming out of this top end. It'll be all blue. Any blue that comes in here is going to end up coming out here. All right. So the idea is now you've segregated the force. You've created something that's creating all one kind of energy or substantially more energy. These are just percentages. So it might be just 60-40, but it might be 90-10. But the idea of the magnet's basically creating a percentage. So your higher, like your N56 magnet would be better than your N25 in the sense that it's creating more of this effect, a higher percentage of segregation. It's more perfect at doing this filtering. And this is just a filter, basically. So now you can understand how this would change the world a bit, because now if there was an electron or proton out here in proximity, that would clearly just be getting the one force hitting it. So it wouldn't be getting the idea of I'm getting attracted here and I'm getting repelled here. There would be just this clear repulsion or clear attraction. And so that's the force, simple, magnified. And so this is your magnet. This is your magnetized force. So it's the same force that made this gravity stuff, in the sense the same force that collected momentum. And I didn't do the shadow idea, but the idea would be as there was another Earth next to this one, you could sort of understand that the force going through this way that got absorbed would create less force coming out this way, and there'd be low pressure, and the low pressure is where they'd move into each other, and that's gravity. And magnetism is, again, just a way of magnifying that effect. All right, so I'll just do a quick thing on, so you can understand the magnetic field. Now, there's no correlation in this example to what would be any kind of space field that you'd call an electric field. There's just no such thing. I mean, this would be, positive charge field, and this would be a negative charge field. But clearly when they're close together, they're going to pollute each other, so it's going to be a magnetic field because it's dipoled. And you'd have to separate them, distance, to create these charge elements, or a duplication of the charge elements. And we don't know of anything in nature that really does that. There's lots of big magnets that are illustrating an electron and proton being right next to each other. So if I put an electron and proton right next to each other, I essentially have this magnet. So those two things would be correlated. But there's no correlation in, you can't create a something in the atom, something atomic, that would be fully like the individual charges. But you can create a charge on a surface, like a balloon, and make it a negative charge. So it's, and you can make the charge stronger and stronger, that is, more and more one color, by making the voltage higher and higher. All right, so the real point I want to make, though, is the electric field doesn't really exist, and all it does is create. So when electricity is moving through a wire, what it creates is a bunch of it polarizes the atoms. So the atoms have an electron and proton. I'll just draw it the simplest way possible, and the idea is is that if this electron gets further away from the proton or closer to the proton, it'll change what the world here sees. So if the electron's further away, it's going to make the outside world's going to say this is more negative, and if it's closer, it's going to say it's more positive. So the atom changes its polarity based on how close or far away these electrons are. And let's just say, for the sake of argument, that what's happening to these electrons is when you pump energy, these little bits, through a wire, what you end up doing is the little bits get trapped between the electrons. And so the electrons push out or push in, depending on how much pressure you pump in. So if I pump pressure into the wire, then I'm essentially creating electrons that are pressurized, that is, they're negatively biased. And when I make that bias in the electron, the atom next to it is going to, and they're all next to each other. These atoms are all connected to each other. and they're basically going to pass that pressure on. So if there's one next door that's lower pressure, then the two of them will balance and create an even pressure between them. So as long as you have higher pressure in any atom over here and you have lower pressure over here, the high pressure will move towards the lower pressure atom. So they're really just pushing the pressure between the electrons. So the electrons would be connected to each other, and there'd be energy between them, tension. And what you're really just saying is I'm going to push one with a little extra energy. That extra energy will be felt here because a little movement here will create a little movement here, create a little movement here, a little movement here. Now it's not really left to right movement. As I'm saying, it's probably up and down movement. But it's the exchange will go from high pressure to low pressure. So this electron was further up, this one's further down. The two of them will neutralize to an even pressure, and when this one will be relatively high to this one, so now these two will equalize, and then these two will equalize, and then these two will equalize. So as long as there is always the guy to the right is lower than you in pressure, you'll keep pushing that pressure in that direction. So as long as you keep applying voltage here, and as long as there's somebody with a lower voltage on the other side, the voltage will keep moving. Now if I have no connection to ground here, that is no connection to very low pressure, then this high pressure will eventually pressurize all these atoms, and none of them will be able to exchange anymore because none of them's lower than the next guy. They're all got the same pressure. So the voltage stops moving. You have no flow of electricity, and therefore you're not creating movement in the polarization. You're not creating ups and downs in these atoms anymore. So you're not making them into dipoles. And so the electricity is essentially moving the electrons up and down, and that movement of the electrons is essentially turning them into magnets that turn on and off as the voltage passes. So as long as you're applying, as long as the current's moving, then you have a field created. But if you stop the voltage from moving, then there's no field being created because you're not making magnets. Because you're not creating changes in pressure. But anyway, so electricity is just about moving pressure through a cascade of electrons that are next to each other. Okay, these are really protons, but just pretend they're electrons for the sake of this argument. And what we're really talking about is these little bits, the ones that are reflecting, are caught between them, and they're bouncing back and forth. And so that's the pressure that's being conveyed. So obviously when the electrons move, the more bounces happen, that means more pressure, and that means the other electron has to move. So we're really just talking about this is where the photons live, this is where they're created, is right here between these electrons and this pressure. Now the real trick is that anytime you move an electron, yeah, I don't know if I want to get into this complex part. Well, the point is when these little force bits hit, they don't just hit and then bounce off. They don't just hit and fall down somewhere and die. Okay, they hit and essentially stick. So when this momentum crashes into an electron, it sticks to the electron. And the electron either gives back because it already is full, let's say it already is full up in terms of it has no stuff stuck to it already is too much stuff stuck to it, then it just gives it back one that was already stuck to it. So if it had a momentum in this direction, it's likely to give up one in that direction. So that's the probability of electrons. That's why electrons seem to move funny, is because they're going to give up almost a random bit of direction in exchanges. So they tend to move in a direction based on the momentum they're keeping. So they're always keeping, if this one sticks and it gives up this, well obviously the split between those two momentums is this versus this, which is something like this. And so that's the angle it end up leaving at. because it gave up a piece this way and it caught a piece going this way. So it's just about what sticks and what it gives up. So there's always a conservation of the momentum. You either keep the momentum or you give it back in some other direction. And that's basically the exchange that go on in the real system. All right, this is probably more detailed than I wanted to get to, because I'm just trying to explain that the word electromagnetism, just isn't a real concept. It's just a word they invented 100 years ago. It's sort of a Maxwellian concept, and it just doesn't. It's just an unfortunate, wrong thing to do. I don't know how to say it. It's a way of saying, like, you could classify a group of animals, and you could say, like, flying animals, and then you'd say, well, okay, they're all the same thing or something, but they would include bats and dragonflies and birds, and you'd have all kinds of different things. It's just not a good category. And the category of electromagnetic isn't a rational category, because there isn't any real, you can't really combine the two things. Electricity in a wire creates a magnetic filter. It turns the atoms into these dipole filters. Okay, it turns this into this. It turns something that's not polarized into something that is polarized. So the electric current makes things into magnets, and then the magnet is filtering the energy of the universe, and that's the energy that makes the magnetic field. So the electricity isn't being turned into a magnetic field, it's turning the substance into a magnet, and by turning the thing into a magnet creates the magnetic field. And the magnetic field isn't some field that already existed. The magnetic field is the energy, okay, that's now been segregated, and so now it has a polarity to it. It's either blue or red by some percentage. It's either pure or it has a bias. You see it is either reddish or bluish, one of those two things. Lean back. Feels a little better when I lean back for whatever reason. Anyway, all right, so let's play some of this, I guess. And yeah, I think this will do.
Yeah, that's doublespeak, isn't it? I think it's like a dog chasing its own tail.
Well, apparently mainstream doesn't see there's an issue there. They don't see a contradiction because they say there is no contradiction, because they say there isn't a contradiction, therefore there isn't one.
Right, so now they're talking about wave-particle duality. Clearly, it is a contradiction. It needs to be dealt with. There's just no point in saying it's acceptable to call it two different things. It's not two different things. It's just wrong.
Yeah, I think that's scientific doublespeak. That's saying that the object I have is all black and all white.
Okay, so here's my take on it. I'll give you my take on it. My take is that Huygens and Descartes and these guys back 300 years ago, they basically hypothesized that there's this thing called an ether. And once they said that, it sort of became a thing that people got fixated on.
So this is the irony, because the rational guy, who's Franklin, the hairy guy's the one speaking now, and he's the nut. And the funny part is he's pointing out how the ether is a nonsense concept, and the Franklin guy's defending the ether as if somehow we need this crap, when I think obviously we don't. So there's a bit of irony here, just because I don't agree with the hairy guy on anything, but I guess we do agree that ether is superfluous.
And we're fixated on that there has to be an ether if light is a wave. And that's just something that was introduced into the thought process by people 300 years ago. So why?
Well, obviously, if light is a wave, there has to be something for it to wave in. So clearly, I would agree with that logic. If you know it's a wave, well, then you should know there's an ether. But I don't think you have any reason to know that light is a wave. the evidence for that is so thin, and I think it can be just well argued that it's just such weak evidence that you have just no right to say, I'm going to ignore the preponderance of the evidence, which says photons are corpuscles, clumps, that basically just exchange momentum, and instead I'm going to believe it's some complex, weird, swirly nonsense because of one experiment.
In 300-year-old thinking.
Probably because, like you said, no one's been able to actually experimentally show what the ether is made out of or that it exists. I think.
Yeah, well, it has a consequence, but again, the fact that nobody can show something doesn't mean that you should logically close the door to there being a possible explanation. So this can also just go to the drag problem with particle theories, and this idea of force existing in the universe and you having to plow through it. Clearly, physics doesn't understand the nature of momentum or inertia or what velocity actually is, why some things keep moving. So if they don't even understand why they do that, how does the universe know the difference between the things, the cannonball shot out of the cannon? How does the universe know that this one should keep going and a cannonball I just placed there with my hand shouldn't move? What's the physical difference, right? You sort of say, well, there's sort of got to be a physical difference between the two things. How does the universe know this one should keep going and this one should not keep going?
Is the same, but it's all just talk, really.
Well, how can you have a wave if you don't have a medium for the wave?
Yeah, I think, as you pointed out, that's the problem, is that there must be a medium.
Well, that's where our thought process has kind of gotten into trouble.
But we're stuck because experimentalists haven't been able to propose what that thing is. And theories like Michael's or Jeff's really don't give us much of a hint. How do you find Jeff's granules? How do you find Michael's ether units?
It's a supposition required by the idea that you have a wave.
What they really should get to is the point that there has to be a reason why things move. So first, get rid of the idea, like bent space, for example. You have to just undo that and just say, okay, wait a minute, there's movement. We're not going to have two different answers for movement. So we're looking for one cause for why things move, whether it's an ether or some other mechanism. But there's a reason why things move, and the likely reason is the same reason, not different reasons. And one of the reasons to say that is because all these forces that cause things to move appear to be moving the same very fast speed. So whether it's a jiggle in an ether or it's just the fact that the force bits happen to move that speed, almost that part doesn't matter which one you choose. Understanding the difference between forces, the things you're calling a field, it's a force, not a field. The field doesn't mean anything unless it's doing a force thing, unless it's pushing something, unless it's creating an effect. And that what's the cause of the effect is that there has to be some elemental force, and that you have to conserve. So once you understand you have to conserve the force, then you can recognize that everything that is moving because somewhere it absorbed some of this energy and it's still holding it. And you can release it merely by crashing it into something, and you'll see the energy get released. You'll see the force come back out.
Okay. And so if you have a wave, you have to have something for the wave to wave in. And so that means you have to have an ether. And then science goes for 300 years and says, well, we can't find any ether, so therefore the ether doesn't exist. And they're presented with this.
Right, but they clearly Einstein said the ether doesn't exist, but then he just created another ether mechanism, a replacement that's exactly the same thing. He created bent space. I mean, what the hell is that but an ether? Come on. It's not a real force. It's this mechanism that causes stuff to move. I mean, what's the difference? You might as well call it an ether. So to say that Einstein said there's no ether when what he proposes is not a mechanical explanation for movement. It's just a description of the effect, the inverse square law. I mean, the bent space is just an illustration of the curve created by the inverse square law. It just isn't an answer. So to say that regular physics isn't an ether theory, when clearly it is. I mean, bent space is ether, and clearly when they say something like a virtual photon causes magnetism, what's a virtual photon but an ether? And then clearly they want to call everything a wave. They say that an electron that doesn't have a frequency, it has no properties of waving, and they're saying it's a wave. Clearly they're obsessed with waves. And again, it has to be waves in what? It has to be waves in fields. Fields of what? Ether. They're just ether fields, right? So this whole quantum field theory thing where they give every single particle its own field, what is that but an ether? How else can you conceptualize it except as an ether? A field that doesn't do anything unless there's something in it? Does that make any sense to anybody? And again, why would I call it a field of like army ants? I wouldn't say that, would I? Would I say a field of army ants? I mean, there either are ants or there's not ants. That's how the real universe looks. There's a light coming off the sun or there's no light coming off the sun. There's not some sort of light field, and then the light field is either on or the light field is off. No, there is photons coming off the sun or there's not. There either is radiation coming off a piece of radioactive rock or there's not. There's no field, the radioactive field, and then we've got to wait for something to stimulate the radioactive field. I mean, that's just superfluous.
Well, we know light is a wave because we measure its properties and it acts like a wave.
Okay, so again, we did this statement that just everybody keeps saying, we know light's a wave, we know light's a wave. You know it based on because everybody says it. But what is the real hard evidence of it? The only evidence of this wave is some bizarre, okay? It doesn't even fit waves because it doesn't make any sense. Somehow photons break in half to create two weird wave spreading things. Photons don't spread. They don't. Okay, realistically, they land as tiny little bits on a screen. They're not spreading. And then somehow this wave they become turns back into a particle. So the wave part doesn't make any sense. It isn't hard evidence of a wave in any sense. It certainly isn't evidence that the photon before it became a wave function was a wave. So, and again, it's only one weird experiment where you start shoving light through tiny little holes, which means you're shoving it next to surfaces. I mean, and logically you can't blame the surfaces for the phenomenon. No, instead you're going to blame the photon. So you ignore the complex thing you're forcing the light to interact with, and instead of blaming the complex thing, you blame the simple thing. It's just it's like a car crashes and it has a baby in the car and a driver, an adult, and you blame the driver for drunk driving or something. It's just retarded.
But we can't find an ether, so let's say that it's a particle, and that means we don't need an ether.
So again, they don't say it's a particle, so this is again just such weird misparaphrasing of reality. Clearly, physics doesn't think any of this shit is a particle. It's just a lie. I mean, it's an insane perversion of reality to say they believe in particles. They think everything is waving somewhere. How can a particle be a wave?
But then they also find out that particles aren't particles, that they're really waves. And so that really complicates the problem.
Yeah, that means that you can't say they believe in a particle theory, and you just say it's obviously a wave theory. And I think obviously it should just be a momentum theory. All we're trying to do is figure out just try to follow the momentum. Follow the force. Follow the stuff moving, the movement. We know the photons are a tiny thing moving very fast. We know they can make something else move, but that, yes, they have a tiny little influence. So you go in, one little photon hits something big, it's going to have to spread its momentum over the whole big thing, and it's going to give it a little tiny bit of movement. Just if I had a big steel ball and I hit it with a tiny little steel ball, I'm not going to make the big steel ball move 50 miles an hour. No, the big steel ball is just going to move a little tiny bit.
Because all of their experiments that prove that particles are waves are based on the assumption that particles are particles and not waves. And
So again, the more convoluted mush. Again, why do people have to have a dishonest conversation? Nobody should. We all should be able to agree that not conventional physics can't have it both ways. They can't call it a discrete clump particle corpuscle and at the same time say it's a waving thing through fields. That's just not possible. And especially for something like the photon, which we know doesn't have any extraneous properties. Photons don't go by you and make your face bend. Photons don't half miss you or do something, affect you in some way. They either hit something or they don't hit something. They don't ever just drive by and create a wind. They don't have any subtle effect. They either hit something or they don't hit something. That's it. Their momentum is either absorbed by the object or it's not. Period.
it's just a big, circular reasoning and, assumptions that may or may not be true.
It's abuse of vocabulary. That's what, like I said, this electromagnetic field nonsense. Again, words should never be shoved together. The whole conversation is broken by this bad verbiage. We shouldn't be saying things can be waves and particles. Call them something else then. If they're doing more than one thing, then they're not the thing. Okay, an airplane, just because it has wheels and a motor, it's not a car. You don't call it a car. You don't call it a flying car. It's just stupid.
Well, I think the one way around this is to just try and identify what would be a physical ether. Rather, there's two ways of doing it. You can either think that your ether...
Look, your ether has to have a finer grain than the smallest particle you know of. So that's your first obligation. Because otherwise there's no straight lines and you lose resolution in your universe. So it's like an Etch-a-Sketch or something. If your Etch-a-Sketch has too big a beads in it, then your lines, you can't make lines in certain directions at all. You're out of luck. So whatever, if you're going to make your ether out of something, it has to be in tiny, tiny, tiny thing. It can't be anything big. It's got to be a minutely tiny thing, like something a million or billion times smaller than a photon. It can't even be a photon. That's too big. Because the photon needs to travel on that medium in almost in very discrete differences in path. The grain of the photon is so fine that the ether that it would have to travel through would have to be insanely granular, tiny, tiny, tiny stuff.
Some particle which hasn't been discovered yet. That's one way of doing it.
Let's go back to Huygens. Huygens, in his book, uses the Newton's cradle. You familiar with this Newton's cradle? That's that thing where you have the balls suspended on strings, and you pull the ball out. I forget whether 5 or 6 balls, and you pull the ball out on the left, and it hits the balls that are at rest, and the ball at the far end moves out. You familiar with that?
Oh, yes. I have one of those.
Well, Huygens starts this whole theory on the basis of that there's an ether and it has inertia, okay, and it transmits waves sort of like this Newton's cradle does.
But again, see, how does that even make sense? Because clearly the ball that swings down and hits it isn't going through an ether. There's no ether. We don't need a bunch of balls to transmit the energy because the ball moved to transmit the energy. And so it's just unnecessary complication. All you're really saying, though, is that what's happening in Newton's cradle is obviously the momentum is being transferred from one to the other. And the transmission could be in the form of even something like electricity. Okay, this conveying of the pressure. But that's all you're really doing is conveying the momentum. You had momentum going one end, and you have momentum coming out in the other end. And all you did was convey that momentum as what? Force. Because that's all it was to start with. The force that comes out of an atom when you have a nuclear bomb is force. Little bits come out. It's the little bits that blow everything to pieces. Right? So what's coming out is stuff moving the speed of light. That's the radiation. is this stuff moving the speed of light. You're releasing the energy. And that was in the ball when it hits the other ball is a bunch of that energy. And the energy just moved right through the other 5 balls and then popped out at the other one. Because it didn't have anywhere else to go. It ran out of conductor. When there was no more conductor, the momentum stopped moving, and so it was all pointing that way, and that's the ball has to go that way because now it owns the momentum. It couldn't give it to somebody else, so it had to keep it.
And so once you start getting involved in this idea of I need a physical model to explain how light works.
You need a physical model if you're going to do physics. So this is the weird thing about this Harry guy and the other Bill guy. There's no point if you're just going to stop somewhere and say God did it. That's not doing physics. You either think there's a physical explanation that comes down to some elemental function. And clearly we have so much evidence that it's elemental in the sense that we're basically, find that you can't do anything to an electron. It just seems like it's an eternal little bit that doesn't turn into anything. You can't find any little bits inside of it or any function that it's not masking anything. Where the neutron seems quite obviously a proton and an electron stuck together very close, and the proton appears to be a bunch of other protons stuck together, some other elemental plus charge elements. But it doesn't really matter because we know that the only ones that function in atoms are the ones in these configurations. That these configurations are the ones that work to create the 100 elements we know of. So to have the 100 elements, they have to be made this way. They can't be made out of positrons. They can't be made out of some other crap and function. There's no matter sitting in here in this room made out of positrons.
And you have to have a kind of a physical ether. And okay, once you've assumed that there's a physical ether and you've said it's got inertia and it's made up of particles that have mass.
So the interesting thing is talking about an ether that has inertia, because that means you have to pre-energize it. And does it mean that the grains themselves all have inertia? Every single little bit of it is moving? Because if you do that, then you're basically where I'm talking about. You're talking about a particle theory. If all your ether is moving the speed of light already, as the universe begins, each little bit of ether is trying to go somewhere, then haven't you already pre-pressurized the universe?
You have to prove that it exists. Okay, well, nobody's been able to prove that any such thing exists. So you're postulating something that can't be proved to exist. So what's
they can't find evidence that it exists, but I'd say more importantly, I don't think there's reason to force it to exist or to think it needs to exist. It doesn't need to exist to explain momentum. We already know the photons have the momentum. We know these other forces that are invisible. We know a ton of the photons are invisible. We can't see them with our eyes. We can't see them move. We can't even see the photons move around us, right? We can only see the ones that crash into our electrons inside of our retina. Those are the ones we even know of. And we know there's plenty of this invisible stuff. And we know there's invisible stuff coming out of magnets. And we know there's probably invisible stuff moving the Earth into the sun. Because it's all doing the same speed thing. The force is obviously applying a momentum that begins at the speed of light. That's how fast the force itself moves. So why conclude anything else? If they all have the same speed as visible light, why would you conclude they're different things? When it just seems logical to say they must be the same stuff, and yes, I can see some of it and I can't see others of it. But I know it's working because I watch what it does. I watch it push things. I watch it push it. Just like as if it was light. Just like as if it was somebody took a laser beam and shot it down.
Doing that.
Well, I think the first step would be to postulate the existence of an ether that is actually made out of things that you know about. Because the two possibilities are the ether is made out of some special particle that we haven't discovered yet, call it like the ether granule, or the only other possibility is that the ether is made out of some composite particle that we already know. So it's made out of things like electrons, protons, neutrons.
It just can't be made out of anything bigger. So again, I don't know how you make that make any sense at all. If the ether was made out of something bigger, then a photon couldn't travel a straight line. It wouldn't be possible. The ether has to be as small as a photon or smaller.
Gluons, tau, whatever.
It doesn't seem to be made out of anything that's material. So why are we trying to make an ether out of something that's material when nobody's been able to do it for 300 years? I think that's just a waste of time.
Well, I think it's worth considering that those are the only two possibilities.
Well,
Well, I don't know. How do you limit the possibilities? I mean, if I'm going to imagine some kind of anything thing, some kind of original mechanism that causes the initial pressure that I always identify as, say, a photon. You know, I can make it out of jellyfish. I can make it out of anything that says it has pressure, it conveys the pressure to its neighbor. Now, the only thing I have to do is make sure somehow it's directional. That is, it will stay on a straight line because it's not making pressure right and left and all these other ways. It has to be saying I'm going one way. So a jellyfish ain't going to really work because that's going to say it's going all kinds of ways. So somehow it has to be a bit that somehow is directional. But, I mean, you can make it out of anything. Little tiny dominoes.
I'm not sure you've exhausted all the possibilities.
But I've been more concerned with the properties of the ether. You know, we have a number of properties. And, you know, I've left it to others, maybe like Franklin and others, to look at the possibility of how it's made up. But you see, ether has become a dirty word in mainstream because of its ancient origins. I mean, it goes back even much further. It goes back thousands of years, I suppose, to the ancient Greeks and further, maybe into ancient India, where they were talking about, you know, something that the whole Earth, the whole universe is filled with, that it's more than another element.
Yeah, well, I think it has some biblical connotations also, because I think it's some kind of, you know, I think it was used as some sort of notion in the creation of the universe or something, but whatever. It just doesn't serve any purpose, because whatever your ether is, it has to have some kind of, it has to move in some way to convey movement, right? It can't create compression and expansion without moving. It's having moving parts. So if it can do this, why can't it do this? Or this? Or, you know, yeah, just get all the way over there. Why does it have to bother? So if I took a magnifying glass, you know, a super universal magnifying glass, I could make this ether really big. Then I could make the ether look like it's moving a lot, right? Because I made it very large, and so now you can see it moving a whole bunch. Well, if it can do this, like I said, why do I need it? If movement is a concept in the universe, what do I need ether for? Why don't I just make things that move without ether?
Really, this ancient concept was adopted by people like Descartes and Huygens, as you say. And then later on, when we started measuring electromagnetic radiation effects, we say, well, they take place in the ether. So we use the same ancient concept of this bearer of light. Now, if you start...
Well, it's just all this notion of what is a field. So again, fields and ether, it's all the same crap, all right, if it's not made out of something. Again, the argument is the ants are real. They're not a field that just sits around not being an ant, and then all of a sudden it turns into an ant. Nothing becomes like at a distance. It just all of a sudden, the ant 500 miles away from me turns into a photon, an ant. So it's a dead ant, all of a sudden goes, turns lives and shoots away. We always see that it has to go from point A to point B. It can't just start at any point and just say, I'm here. So we know these ants always come from something. And they come from something that's already stored the energy. And storage is another, so it's just so important to these whole subjects, right? Because the previous, the chat they had this last Saturday was some nutter who was saying he has created some machine that can break momentum, conservation of momentum, and it has spinning wheels in it. And I kept through the whole video, I was just saying, will somebody please point out that a flywheel is a storage device. It's a battery. So the idiot was basically saying that, well, here I have a charged battery, and I put it on the table. Oh, it's violating the conservation of momentum laws because I'm running a motor with it. Yeah, it's a charged battery. Of course you're running a motor. Of course you've violated conservation of energy because clearly you charged it ahead of time. It's already charged. Obviously, if you have spinning wheels, you've already charged the system. It's a battery. Obviously, you can say it's free energy if you don't have to account for spinning the wheels. Duh. Shit.
A quantum foam vacuum or something like that, you'll be listened to in mainstream circles. But if you mention the word ether, you're liable to lose your job. I think I told you about
Oh, this is such baby talk. I mean, you can mention ether if you want to call it that, if you can account for it. But I mean, what is the difference? I mean, what's the difference between somebody saying quantum foam or magnetic field? What's the difference them saying ether? I mean, are you just, is the word ether some sort of precious thing to you, or is it the concept of ether that you care about? Because clearly they've accepted the concept. Saying there's some bent space-time field that can be warped, isn't that as ether as you get? So what are you complaining about, in the sense that if you want them to accept ether, they've accepted it. They're just telling you have to call it a field instead of calling it ether. Well, what's the fucking difference? A field of nothing that waits to be perturbated with ants. You know, a field of dead ants that waits for animation energy to go through to animate the ants, or life energy has to go through to make the ants alive. They're dead ants until the living force shoots through the field. You don't need any of that crap. They're actual ants. They move from point A to point B. The light from the sun moves from the sun to the earth, and it takes time to do that. That's the evidence that you don't need the fucking ether. If there was a fucking ether, then there shouldn't be a speed of light. You know, it should get here instantaneously. You tap on one side, boom, and it should pop out the other side.
a research student who told me some years ago that his professor had secretly told him, sworn to secrecy basically, but he didn't give any names, so I think he didn't.
So there's another subject I meant to mention in the other video the other day. You know, when the electrons are exchanging the pressure with electricity, right? And this is the same goes for like the transmission of light through a medium. You know, they keep talking about how light slows down and blah, blah, blah. It doesn't really slow down. All that's really happening is that there's little pressure bits in between the electrons are moving the speed of light back and forth. So any movement in this will automatically create a change in this distance, which that will happen at the speed of light. And so when this moves a little slow, okay, then it'll change the speed of light. So most of the movement of the pressure happens at the speed of light, and only a tiny bit of the movement happens to these objects. So you can sort of understand what the degrade in the speed is, right? Because the force moves this moves slower than the speed. The electron moves much slower than the speed of light, right? So that slows down the process of the pressure moving. But 90% of the distance happens at the speed of light. So 90% of the action happens at the speed of light, and only 10% happens at this slower speed. And the slower this speed, the slower the transmission. So different substances, the electrons are at different spacing, so that's why it takes longer through one kind of glass than another kind of glass, or through steel, or through this, or through that. The transmission speed is completely dependent on how much pressure is between the electrons and how close they are together. How much movement of electrons versus how much movement of the force moving the speed of light between the electrons. And that's a perfectly rational explanation for why transmission takes a little bit longer, because it's not all happening at the speed of light. Some of these bits are moving a little bit, and that little bit of movement by them is slowing down the overall time.
That he actually believed in an ether, but it was as much as his position was worth in the university to admit that to his peers. So that's the difficulty.
There's just some personal little anecdote stories that are always quite useless. Who cares?
I think, facing us with the whole concept of ether. I mean, Aristotle, for example, conceives of the ether as a sort of something inertial, which gives rise to the slowing of objects. I mean, contrary to Newton's first law, he says that an object will go to absolute rest if it's imparted with an external force. That force will die out, and it'll have to be imparted.
Right. Well, he lived in a world where space travel and all that stuff was completely inconceivable. So yes, in his world there wasn't any frictionless environment. So of course it would seem like everything ran out of gas to him because yeah, you could only throw a rock so far and it fell down, and you know, just wasn't much fun.
Continuously with a force to keep it moving. Well, he conceived of the ether as sort of like a frictional medium which is slowing the system down. It's sort of like
yes, because he lived in a world of air and water, two mediums. Space isn't a fucking medium.
Thing.
Well, Aristotle basically objected to the concept of void and said that a void doesn't exist. But physics has adopted the idea that space is a void. And so the universe consists mostly of...
So this is a guy who's now he's complaining about... So a minute ago he doesn't like the idea of ether, and now he doesn't like the idea of a void. Now, don't you have to have one or the other? Is there really some other option? Space is either something or it's nothing, right? I mean, there's either nothing with force bits in it and particle matter bits in it, or there's some ether structure. Is there really some other alternative? I mean, I really don't think there's any alternative, right? They're either space is either made of something or made of nothing.
Nothing and matter interspersed within it. And I think that's where the problem lies.
So again, he thinks the problem lies with ether, and he doesn't. So he doesn't like ether, and he doesn't like empty space. You know, what the fuck? What does he want? He wants God. That's all. Call it God.
So, Michael, you have a comment?
Well, my version of the ether unit would be counterintuitive.
Oh, I don't know why he asked Michael. I mean, this guy just goes on and on about his stupid doopy loop-de-doo. I'm just going to make up a Three Bears story. Here you go. I say Goldilocks farted the first wave in the universe, and that wave banged into Little Red Riding Hood, and she had a faint, and when she fainted, she fell in a big pile of unmotivated, dead ants, and the dead ants all popped alive and flew through the universe and made everything happen.
According to our logical perceptions, but the only original substrate that for a universal ether would have been original space. So if original space had
original space, I mean, just what would you just sit here and say what? Original space. Original nothing, as opposed to the later nothing. I mean, just where do you go with this mush? You just you always just want to, you almost, it's like, it's just so pathetically stupid. Original space. What? You just can't. You're saying, how can you have a conversation with people that could say a word like original space and think that could possibly mean something? Original space. As opposed to used space, or what? It's just so stupid.
Had point localities which were oscillating, and then you had a yin-yang combinational pair, and then...
Yeah, it just made this shit up, right? So, yeah, well, the universe started with Binky, okay, a one-eyed goldfish, and he was really lonely, so he did some experiments and built himself a second Binky, and then the two Binkies kept banging into each other, knocking their scales off, and all their scales grew into other Binkies, and then the whole universe got full of Binkies. I just, what the fuck? I mean, it's so made up. You're just saying, why do you think I'm going to believe this gingerbread story? That you just made all this crap up. I mean, this is just like Hansel and Gretel or something. You just made this crap up. There's no fucking witch that burns, cooks kids in a oven or anything. That shit's going on.
To necessarily reversibly revert to singleton units that would have broken the perfect symmetry of the oscillation. But this would mean that the transition to a vibrational ether would involve massless units, and you would have empty space to allow for enough room for the vibrations. But basically,
yeah, empty space as opposed to original space. What? I mean, it's just so fucking made up.
The ether unit would not be substantive; it would be massless. So that's, like I say.
So more of this massless crap, just the people do this with these photons and everything. Obviously, you can't measure the weight of the smallest thing, just as you can't measure the distance of the smallest thing, and you can't measure things bigger than your rulers. You just can't do it. If you got like a 10-inch ruler, you can't measure something 20 inches with a 10-inch ruler. Just can't do it. So why are they pretending they can do this stuff? That they can measure the weight of a photon. But to say it doesn't have any mass is just kind of retarded. Because you can't have momentum without having mass. Your velocity can't mean anything if you don't have any mass to go with it. So it has to have some kind of mass. It's just stupid to say it doesn't have mass. Because of course it has mass. Because it gives it to the thing that's moving. The bullet has mass because of the velocity in the direction it's moving. It's really fucking heavy. Bullets are so fucking heavy in the direction they're moving that they'll go right through your fucking head. That's how heavy they are in the direction they're moving. So they must have an awful lot of mass in that direction. They came from something. Oh, that's right. It came from the little photons that push the bullet. That are in the bullet. Jeez.
Would have been. But original space theoretically may have been more self-compatible and different from space now. It had trio forces, and who knows what original space really was like.
Okay, Bill Lucas, you have a comment.
Yes, there's a number of...
So this is the compulsive liar, crazy creationist kook guy. So just letting you know.
You may not be addressing it yet. I'm not sure. I just joined. But you've got the concept of...
I don't know why. Franklin's been doing this a while. He should be able to figure out there's a couple of assholes have their microphones open and they're doing all kinds of bullshit in the background making noises. And he doesn't do anything to fix it. It's just so annoying.
In experiments, the electromagnetic field has tensile strength.
So in experiments, the electromagnetic field has tensile strength. There's no experiments. There's no evidence for any of this crap. There's not even an electromagnetic field. Again, there's either a magnetic field or an electric field, and those two concepts are just vaporous nonsense. There's no experiments that shows you any fucking field. All you see are ants. You don't see fucking fields. There's no experiments that sees the field without the ants in it.
And you've got the question is, can you have action at a distance or only local effects? In other words, if you have...
There's no action at a distance except at the speed of light. So there's only action when ants go from point A to point B and make something happen. So again, what's the point of this nonsense? There's no action at a distance that we haven't already accounted for that it happens at the speed of light. And the entanglement crap is crap just because obviously if there was any entanglement we could use it. The very catch that they say somehow, oh yeah, somehow there's stuff happening by ESP, but somehow it can't win the lottery. It's one of these catch-22, get out of jail bullshit. Oh, God wouldn't allow you to have ESP to win the lottery. There's rules. ESP can only be used for silly things like counting how many donuts are in your cabinet.
At a distance, what is conveying the force? And if you have an ether, what is conveying the force in the ether? And
Well, obviously the ether would be conveying the force. That's what the whole fucking point of having the ether is the ether would be doing some kind of domino thing and allowing the force to be transmitted through the ether. So, of course, the ether would be transmitting the force.
The experiments have shown that the electric field has tensile strength.
All right, so he said it again. There's no experiments. There's no tensile strength. The field isn't some solid object. It's just absolute nonsense. There's no evidence of that. You can plow photons right through it. It's not made out of some solid thing. Just bullshit.
Means they can't be consisting of particles. The electric field.
Of course it can be. There's absolutely no evidence disputing the fact that it's just a kind of radiation, and that radiation between two electrons will create repulsion because the radiation creates momentum.
A continuous entity, and that's how it makes all electromagnetic forces local forces, not local contact forces, not action at a distance. So
yes, they're all action at a distance. It takes the force time to get to another place. Nothing instantaneously transmits momentum. It always has to be transmitted through one of these modalities, these forces that move exactly at the speed of light. Some kind of ant has to go from point A to point B to convey momentum.
how what you all are describing describes the difference between action at a distance and local contact forces.
So just absolutely mush. I mean, everything that happens by means of a force ends up being what we call action at a distance. Even if I use a laser beam, it sort of feels like action at a distance, right? I mean, I sit here and push the button on the laser beam and I make a little piece of wood move across a little bucket of water. I mean, I'm going to feel like I'm doing action at a distance, right? So we're always going to call the action, when we're not physically having to go touch it, action at a distance. But we do know that even when I go to touch it, what's going to really move the thing isn't going to be anything but magnetic adhesions. You know, the electrons here are going to affect the electrons on this thing, and they're going to repel each other, and my skin isn't going to go into the other piece of skin because of that repulsion.
I'm not sure that I got an echo going on here.
Process issue.
Well, I would like to address the issue as to whether the existence of tensile strength means that you don't have particles, because I'm not sure that's true, because if I had a long cylinder and I had a piston at one end and a piston on the other, if I pull the piston out on one end, it's going to immediately suck the other piston in, and that's an example of tensile strength, right? You've got these two pistons, and you pull one, shoves the other, pull the other one. So, and definitely know that the thing that's in the tube, which is air, is made out of particles. So I don't know that the existence of tensile strength has any speaks as to whether it's particles or not. I think particles are
I think clearly there's just no evidence that it has tensile strength, so it's just silly. It's not made, the field is not made out of atoms or electrons or any of that stuff. So again, it's just nonsense to say it is. It isn't. Okay, so the fields that are moving the speed of light can't be made of something. Now, conductors can be, our atmosphere can be. So obviously if you have electric discharge in our atmosphere, that could have tensile strength because those are the actual atoms that are being charged. But the field itself can't have any. The field is just it's like saying that a spray of water, you know, I put my finger over the hose and I spray water in little tiny droplets, that the droplets have tensile strength. They don't. They're not connected to each other. They're free-moving hunks of momentum.
Rate the two by miles, I won't see any effect if it's...
Yeah, you would. If you had a tube that was miles long, you pull one end, you know, it would suck in the other end miles away.
Not very quickly, not at the speed of light.
Well, it would do it at the speed.
Yeah, well, why would you expect it to do it at the speed of light? So again, we're just nonsense. Of course, you wouldn't expect the idea of the fact that atoms are connected to each other by you know, pressure, an atmospheric pressure, And that, yes, you can't change you change the atmospheric pressure at one end, it's going to take time for it to travel, would be probably the speed of sound, or something like that, because that's the compression of the atoms. That's how much time it takes to compress atoms. You have to move the entire atom, which moves much slower than a freaking electron. The bigger the thing is, the slower it moves. Duh.
Obviously, in
But we measure it at the speed of light. So it has to be something related to light.
Well, I was arguing about not light, but the concept that tensile strength is a property of, say, only solids. But certainly tensile strength is obviously a property of solids. If I have a solid bar and I pull it to the right, obviously the end is going to go to the right as well. And I'm just saying that you could have a thing made out of particles between those 2 points, like...
Well, again, it's just this word particles again. You're just getting into trouble. Obviously, it has to be things that are charged, because they have to have something to connect them to each other. So clearly, they have to have some atomic structure with electrons and protons and some ability to have some reason to either repel each other to create tensile strength or to attract each other. But there has to be some mechanism of attraction or repulsion, or there can't be anything called a tensile strength. So again, it's just bullshit. Radiation coming off of a radioactive isotope doesn't have any tensile strength. It's little bits of energy, little corpuscles that are not tied to each other in any way whatsoever. They're all little free bits.
You bend the plungers, and if you pull the plunger on the right, the plunger on the left is going to also move in concert with that one, which is like another guy. I would say that's a demonstration of tensile strength. So I'm saying that, yeah, you got tensile strength, but that doesn't show that the medium is solid, for example. The medium could still be this particulate thing that we haven't identified. But I think it's important to go back.
So again, the medium should be not worried about. We shouldn't care. Who cares, again, if you want to call it an ether or you want to call it photons? You want to call it a compression in an ether or you want to call it a clump? The point is that we know the momentum is elemental. The momentum is in little clumps, and it moves from point A to point B in generally straight lines, and there's a few certain rules about how it behaves. Now, 99% of the experiments will show that these bits of radiation, like the radiation coming off an isotope or the radiation coming off a magnet, it's radiating in this like a light bulb fashion, little bits flying off at all angles, independent of each other and diverging with distance, creating the inverse square law, all that crap. That's how it works. It doesn't work like anything waving. So the only one little experiment, the stupid slit experiments, where you start jamming photons right next to surfaces, and all of a sudden you decide that photons are waves because of that. It's just stupid. It breaks all of this logic, because you can't do the momentum thing in the form of waves. You can't transfer the momentum. It's clumps moving the speed of light, and that's what all of the energy in the universe looks like. Again, everything that's moving is moving because some clump somewhere hit it. Clumps, energy hit it and stuck to it, is stuck inside of it, moving still.
Laurie's presentation, which is she was just trying to describe what the nature of why E equals HF. Well, why is light quantized? Because this is the main reason why people think that light is could be the photon. But going back to what Bob said,
so again, and even the word photon, again, it's just all this broken vocabulary. Because, like, you know, it's already sort of been established that photon is saying the wrong thing. Because we know this photon comes in rays. There's an amount of it. And that for us to see it, it has to be at a specific frequency. These corpuscles have to be at. So a photon isn't one little thing. It isn't one quanta of energy. A photon, for us to receive it as a light photon, has to be more than one quanta of energy. So even the word photon doesn't even say it anymore. It's just the wrong word. Damn it.
that light actually acts differently. It has different regimes. There's the atomically generated light, which does come out in specific energy quanta, and it moves like a bullet in that it moves in straight rays, versus, say, a sound wave being generated.
Okay, so again, a sound wave isn't the same form of energy, so it's just pointless to talk about it as if it is. Because we know what the sound wave is, which is energy that's moving whole atoms, not just moving electrons, and so it's going to move much slower. Now, yes, there's still force that's always transferred. So even if I push this pen into my hand, the pen isn't going into my hand, the force is going into my hand. The force puts a dent in my hand. The force does all of that. The bits trapped between the electrons, the repulsion between the electrons, the little ping pong balls are what's really going to be creating the pressure. All right, the ping pong paddles aren't doing it. The paddles never hit each other. The paddles just say, there's too many ping pong balls here, you have to move away from me. They just create pressure. So all you're doing is compressing the ping pong paddles in my hand. They were this far apart and this far apart and this far apart in my hand, and when the pen pushes in, they get this close and this close and this close and this close, but they get no closer because it's too much pressure between them, and then they spring back. So all you're doing is compressing things, creating more pressure, so they'll spring back. But that's all there is. Alright, probably enough of a video. I mean, I could play more of it. There are more preposterous parts, but I guess we'll maybe do that some other time, because it just goes on and on and on and gets rather redundant. So we'll say this is probably enough. And so till the next time and such. I think so.